Hello there, Mr. Sutton here, bringing you this lesson on the Pythagorean Theorem. In this one, among many other things, we will be using the Pythagorean Theorem to find side lengths in right triangles. And as just one of many applications, we're going to use this to find the length of a ladder. To start things off, we're going to play a little spatial game. So let's say I start with a triangle. It's a right triangle. And I love this triangle so much that I'm going to put it in a box and fill this box with 3 more copies of this triangle. But they're going to face different directions. So here's another copy, here's one, and here's another one. And again, these are all the same triangle, just cut and pasted facing different directions. I'm going to give names to the 3 sides of this triangle. The short side we'll call A, the next longest side B, and this longest side across from the right angle, I'll call that C. Since this is the same triangle, all of these sides really have a length of C. So this is a square, this is a white square. And the area of it then is just going to be C squared, which is just one of the sides squared. Now let's take these triangles and I'm going to move them along with this box over here. Here's this triangle, I'm moving it over here. And I'm going to take this other triangle and put it right on top of the first triangle. And these other 2 triangles got to go too. So this one's over here, this one I'm going to move over there. And here are the original triangles, just in case you were wondering, this kind of looks weird with these letters floating, so I put them back. But now let's take a look at the white space in this other box. So these triangles didn't change size. This is the same size triangles, so that means this white space is also the same area. It's just been split up and rearranged. The area of this white square is going to be just this short side squared, A squared. And then this white square is going to have an area equal to this second longest side squared, B squared. Again, since this is the same amount of white space, we can say A squared plus B squared equals this area, C squared. And we have just proven the Pythagorean theorem. Let's go ahead and officially define it now. So the Pythagorean theorem assumes that you have a right triangle, and just to give these different sides names, this long side, longest side, that's across from the right angle, we call that the hypotenuse. And these other 2 sides that are not the hypotenuse are called the legs. Specifically, they are the legs of the right angle. So we can say that if you have a right triangle with legs AB and hypotenuse C, A squared plus B squared equals C squared. And you've probably heard this since middle school, but now we're going to use it for a few things. So here's a right triangle, and we want to know the length of this unknown side in simplest radical form. Pause the video and see if you can already use the Pythagorean theorem. All right, you can start by writing it out. A squared plus B squared equals C squared. And the most important step here is making sure you plug the correct thing in for C. A and B are interchangeable, but C, you got to get the correct side there. So that's always going to be the longest side, which is always across from the right angle. So that C value will be just X. And so we can say 20 squared plus 30 squared equals X squared. Well, that's really 400 plus 900, so 1300. And then to find value of X, we just have to take the square root of 1300. But they want simplest radical form. So if you have the square root of 1300, how could we split that up? Well, the biggest perfect square that goes into that, since it has 2 zeros, it definitely 100 goes into that. So we can split this up into the square root of 100 times the square root of 13. The square root of 100 is 10, so 10 root 13. Now, some of you might be wondering, since we square rooted both sides of an equation here, why are we not writing the plus or minus? Well, let's think about what we're finding. This is the length of a side of a triangle. Can we have a negative side length? No, we cannot. So although algebraically there's a negative solution to this, we're going to forget about it because we can't have negative sides. Let's do a real-life application. You want a 13-foot ladder to reach 12 feet up the side of your house. How far away does the base of your ladder need to be from the house? Pause the video and see if you can wrestle with this one. All right, let's see how it went. I would start by drawing a diagram. So there's going to be a triangular situation here. We've got the ladder as our hypotenuse. The base, how far away the base of the ladder is from the wall, that's going to be our base of our triangle. And then the height here is how high up on the wall the ladder is going. So we can say 13 feet for the hypotenuse, because that's the length of the ladder. And this side here is going to be 12. That's how high up you want it to go. And we're looking for this base here.
So Pythagorean theorem again. Now this time we've got 13 for the hypotenuse, so we can say x squared plus 12 squared equals 13 squared. So that's 144 and 169. So x squared is going to equal 25 if we subtract 144. And then square rooting both sides, we got x equals 5 feet. Before we do anything else with the Pythagorean theorem, just want to show you a neat little shortcut. These are called Pythagorean triples. These are just common right triangle side lengths that if you see two of these side lengths in a right triangle, you kind of get the third one for free if you have these ratios memorized. The most common of these is the 3, 4, 5 right triangle. And this also works for anything that's in the same ratio, like 30, 40, and 50, 60, 80, 100, anything in a 3, 4, 5 ratio. If you have two sides, you know the other one. This is by far the most common. If you don't remember any of the other ones, you should at least make sure you know this one. Some less common ones that you will sometimes see are the 5, 12, 13 triangle, the 8, 15, 17, and the 7, 24, 25 right triangle. And again, anything in these ratios, you can also use these ratios to find the third side. At this point, we're going to use what we've learned to find the area of this isosceles triangle. Now, what's the area of a triangle again? Oh yeah, 1/2 base times height. So if we knew the height of this triangle, the length of this altitude, we could just multiply half of that times the base of 6, and that would give us the area. So we need to find this height. Now, one thing that might help us out is that in an isosceles triangle, the altitude bisects the opposite side. So that means that each of these segments here is going to be 3. So then, what is the length of this altitude? So you could do Pythagorean theorem and do like x squared plus 3 squared equals 5 squared. But hold on a sec. You guys know about Pythagorean triples now. In the 3, 4, 5 right triangle, if you have one of the legs as 3 and a hypotenuse of 5, and this last thing in all those ratios is always the hypotenuse, well, then what does the other side have to be? Well, it's got to be 4. So that means we have a height of 4. So 1/2 times 6 times 4 is going to give us 12. So we did save a little bit of time not using the Pythagorean theorem, again, if you remember your Pythagorean triples. You could have used Pythagorean theorem, but this does save you a couple minutes. For our last problem, we're asking, is this triangle a right triangle? So if something is a right triangle, then the Pythagorean theorem should work for it. What that means is, if it's a right triangle, plugging the sides that they gave us into the Pythagorean theorem should give us the same thing on both sides. So which sides do we plug in for which letters? Well, remember that C is always the biggest side. The hypotenuse is always the biggest. So we don't even actually need to know which one of these is supposed to be the right angle. We just plug in 10 for C. So we have 6 squared plus 8 squared equals 10 squared. So 36 plus 64 equals 100. And is that true? Yes, it is. 36 plus 64 is indeed 100. So that tells us that this is indeed a right triangle. Now, you actually could have saved a little time on this one. 6, 8, and 10, if you reduce that ratio by 2, you've got 3, 4, and 5. So there it is again, those Pythagorean triples. If you know those are there, you could have said that this is really a 3, 4, 5 triangle and saved even more time. So that's it for Pythagorean theorem. Until next time, this is Mr. Sutton signing off.